In this video, I'm going to just talk through the three most common 5-mark questions on having to prove these rules within Euclidean geometry. And so you probably have got this from your teachers, and so I'm not going to bore you with all of this. You can pause the video, take a screenshot if you want to copy it down, but just to discuss it. And so if you had a question where you had to prove that the opposites were supplementary, but you didn't have any radii, you just literally had this bare block, this bare cyclic quad, then what you would need to know to do is immediately you would need to fill in and create the radii, because then you can let the one side be x, then the center is double. Then you do revolution, so you do the other side here, which will be 360 minus 2x, and then again you could call this half of the angle that's at the center. If the angle at the center on this side was 360 minus 2x, then the angle at the circumference will be half of that, and just like that you've proved that the opposites are supplementary, that they add up to 180. How do I do this question? You would be asked to prove the theorem that states that the angle at the center is double the circumference, and so you'd need to know to create a diameter or a radius that's just got a bit of a tail. And then what you'd know is if these are all radii, I can let this be x and this be y. Then because this is an isosceles triangle now, that would also be x. The angle outside, the exterior angle of this triangle, let me just fill this in, would be 2x. If this is y, this would be y, isosceles triangle, and the angle outside would be 2y. And so what have I got as a summary of angle at the circumference? X plus y. What have I got as a summary angle at the center? 2x plus 2y. Or if I took out a 2, it would be x plus y, which is double the circumference. Last one. If you get asked to prove this theorem where you've got to prove the common tangent theorem where this angle is meant to be equal to that, again you draw a diameter, you construct one, and you join it to the angle that you're trying to get equal to x. Then if this is x here, then you're going to tap into the rule of something from the center, because this is a diameter, is perpendicular to a tangent. So if this is x, then the next door little neighbor here must be 90 minus x, and your reason for that would actually just be adjacent angles. Then you do angles in same segment, and so that's maybe a little bit more difficult to see, and so I'm purposely going out of the lines just to show you that there's your angle in same segment. And so this little angle here would be 90 minus x. And if you've got a 90 minus x, but you know that because this is diameter, this whole angle should be 90, angles in semicircle, then if this is 90 minus x, but the whole angle there is 90, then this angle there must be x. And that's how you prove that this is a tan chord theorem. And so those are your three most common proofs. The other one, which I haven't discussed in this video in depth, is when I've got a line from the center, and let's just say it's perpendicular, then they'll ask us to prove that it bisects. And the way that you prove it very briefly is you draw your radii again. And so even in that, you've noticed that all these proofs require construction of either radii or diameter. So if you get a blank, you know that. And then you're pretty much going to just be doing some version of congruency. And so in this case, you'd have the sides are the same in both triangles. This side is common, and you have a right angle. So you'd prove it by right angle hypotenuse side. Therefore, if they're congruent, these two lines would be equal. The other way they could ask it is they could say, these are equal, prove that that's 90. And again, you draw the radii, so these are the same, and you'd have side the same, given, side the same, common, therefore they're congruent, therefore all their angles must be the same. So these angles would both be 90. I hope that that discussion around the proofs in Euclidean geometry were helpful for you. And you know that you're going to get one of them for 5 marks pretty much in any paper you write from now onwards. So it's helpful to know these. If you found this useful, please like this video, subscribe to our channel, and share this with your friends. Thanks.